How about now? Haha! I've been working on this. Carimera. Yeah? 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 Okay. Yeah. Don't clap too much. Good morning, everyone. I'm here from Mozilla. We're really excited to sponsor this event and be here in Athens. It's my first time in Greece. It's beautiful. I'm having a lovely time. I am Potch, and I am a developer advocate at Mozilla. Mozilla, you may know us for the Firefox web browser. What you may not know is that Mozilla is a nonprofit organization dedicated to keeping a healthy, open, and accessible web and internet. So we're not really here to make a ton of money. We're here to make sure we exist to ensure that the internet remains free and open for everyone. And one of the ways we do that is we make a software product called Firefox that tries to embody as many of our values as possible. And that is why Firefox exists. Firefox has been around since 2004, so it's now a teenager. It's getting a little up there in age. And ever since the beginning, Firefox has used Gecko as its rendering engine. Gecko has existed before Firefox actually even existed. And that means that Gecko is, ultimately getting a little long in the tooth. It served us very well. It's still competitive. But we wanted to take a look at Gecko and see what's next. So I'm here to talk to you about the future of Firefox. In Mozilla, we have a project that we've started called Project Quantum, and mostly because we like Quantum Leap. I'm here to explain to you a little bit about what Project Quantum is and what you can expect to see changing in Firefox over the next year. So, how did Project Quantum start? It actually started with a little research project called Rust. Rust is a programming language that is sponsored by Mozilla. We didn't create the language, but we support and employ many of the core developers of the language. But Rust has a very, very large open source community. How many of you have heard of the Rust language? At least you've heard the name? Cool. How many of you have written any Rust? Yeah, that's okay. That's okay. So Rust is really not very like JavaScript at all. In fact, Rust is a systems programming language that runs blazingly fast, prevents segmentation faults, and guarantees thread safety. This is different from a lot of other low-level programming languages in that if your program compiles, that means that you're not going to have certain kinds of memory issues. You're not going to we actually guarantee at compile time that you're not going to run into memory safety issues or thread safety issues, which means if your program compiles, you can actually say, we know this is going to work in a multi-threaded environment, or we know it's going to work without accidentally revealing chunks of memory it shouldn't to the world. Most of the security issues that we've had in the past couple of years on the web are due to these kinds of problems. And so Rust was sort of built with the idea of solving these things. So if you can have multi-threaded parallel code without any thread safety issues, you can guarantee that at compile time, what can you do? Well, what you can do is you can take Rust and you can actually use it to build a browser. It turns out browsers need these sorts of things. In fact, the browser that we're working on is a experimental research-only browser right now called Servo. And Servo is the idea of, it's the year starting year 2016. It's the 21st century. If we could start completely from scratch and build a browser today, how would we do it? And the answer is we would take advantage of a lot of small parallel computers. When we started building web browsers, there was one CPU in your computer, maybe not even a GPU in your computer, no graphics card. And over time, people had the expectation that your computer was just going to get faster and faster and faster and faster and more powerful. And that was true up until about 2003. Then it stopped being true. Turned out that making just a faster and faster and faster computer is very expensive, and your computer gets very hot, and it uses lots and lots of electricity. And that's actually not very sustainable. You don't want your computer to be heating your entire house, especially in the summertime. So what we end up doing is making lots and lots of smaller computers inside of our computers and specializing them. For instance, every device we carry, including mobile phones, has a graphics chip in it that's dedicated only to doing graphics. And we have multiple small CPUs in our computer, that even in our phones, that can do multiple things at the same time. So what if we built a browser that could take advantage of all of this? That is what Servo is. Servo, you can actually download builds of it, experiment with it today. But the cool thing about Servo is certain pieces of Servo are actually more or less ready to be used. Servo's probably itself a couple years out from being a real full browser. However, pieces of Servo are ready today. And what Project Quantum is to, like Voltron, it's actually multiple pieces, and we're going to go say, hey, this piece of Servo is ready. And we're going to unbolt it from Servo and carry it over here and rebolt it into Firefox. We've actually begun doing this work, and there's a couple big pieces I want to talk to you about that are going to really, really change how Firefox works and really, really make your code that you put on the web run that much better. So the first piece is the Quantum Compositor. This is actually already in Firefox as of the latest version. This is a multi-process architecture split. We've been moving toward a multi-process architecture, and this is a way to prevent graphics crashes. A lot of times when your browser or software crashes, it's because the GPU in your computer is misbehaving, or there's a badly written driver, and it makes your browser crash. So we've actually started running all of the graphics compositing work in its own process. And if it crashes, we just restart it. But the browser doesn't crash. So we've eliminated a ton of crashes that were caused by buggy graphics drivers. And this way, even when your graphics drivers go to sleep, we wake it back up, and you don't even hopefully notice that there was an issue. So this is already in Firefox, and it's really just kind of, if you don't notice it, that means it's working. The next thing is something we call Quantum CSS. Internally, sometimes we call it Stylo, which is the combination of style and servo. Turns out that if you are calculating the computed style, so we have the DOM, and we have this bunch of style sheets, and we want to say, what is the style of each element in the DOM? Well, that work can mostly happen in parallel. For the most part, as you compute this big tree, once the tree branches, those two branches don't depend on each other anymore in the DOM. And that means we can take each branch and give it to a different core of your CPU. And what this means is if you have a 4-core CPU, we can compute style 4 times faster. So this means if you're doing lots and lots of style changes to your page, for instance, animating properties that are not in the magic trifecta of transform and opacity and things like that, they can still run very, very quickly. So we're actually trying to make it possible to animate more properties on the web by recomputing computed styles faster and faster and faster. This will be landing sometime this year. We have Quantum DOM. Quantum DOM is an approach we're taking to actually start scheduling and prioritizing and throttling background tab activity. Turns out we did some measurement, and a full, 2/3 of background tab activity is just JavaScript running in the background that's tracking you on the web. It's just ads reloading data, it's sending data back to the server. So why should that background activity slow down the tab you have open? It shouldn't. So we've started to identify background tab activity that is sort of detrimental to your foreground tab experience, and either slow it down, pause it, or suspend it entirely, depending on the needs of the foreground tab. Say you're playing a game or something relatively resource intensive, we can actually recognize that and take it and talk to all the background tabs and say, hey, you're not priority right now. But we're trying to make sure that we do this intelligently. So let's say you have a background tab that's streaming music. We don't want to pause that because we know that that's something you want happening in the background. So it's a big project to identify, categorize, and sort of manipulate background tab activity. What this might mean for developers is it might mean if you have a set timeout loop in the background, depending on what it's doing, it might not happen every 100 milliseconds. It might happen less often. We're going to try to figure out a good balance to make sure that background tab activity is still respected, but we're trying to really prioritize what the user is doing in the moment. I have a second slide called Quantum DOM, and I'm not sure why, because it's great. One of the big pieces of Quantum that's coming is called WebRender. WebRender is the rendering engine inside of Servo. Specifically, it's the painting engine inside of Servo. Traditional painting on the web involves a bunch of different steps, a lot of which actually happen on the CPU. Calculating the curves and pixels of the type and the text in your fonts that you render, that's currently being done on the CPU. A lot of individual painting of borders and border radiuses and colors and gradients, a lot of that's actually being done on the CPU right now. We think that's pretty silly. It's the year 2017, and it turns out most video games do all of their graphics on the GPU, and that's how they get 60, 90, 120 frames per second. So that's what WebRender is all about. We're actually attempting to re-implement entirety of web page paint, all of the painting you do on a web page, entirely in the GPU. Sort of a quote from Patrick Walton, who is one of the people working on the WebRender project. We've removed painting from the bottleneck in Servo. What does this mean? Good painting performance on the web right now is 60 frames a second. I'm sure you've heard the 60 frames a second number. With more intensive things like VR, 90 frames a second is really what you want to be doing. With WebRender, what we've observed in our preliminary tests, and these are very preliminary numbers, is web pages are now painting approximately 300 frames per second plus. More than enough room for even a complex website. That means that your code, a lot of times we come up here and say, you need to write your code to run more efficiently. Well, we're also trying to make sure that your code runs more efficiently on our side. And we're trying to make it a big balance between you encouraging and teaching developers to make their code more performance, and also just making the browser faster. Why can't the browser pick up some of the slack in the slow web? We want 120 frame per second paints across the web. That's our big goal. This is a huge project. It involves completely replacing our painting engine. It involves huge banks of tests where we have old image of web page, new image of web page, and making sure that they pixel match. So when we roll out WebRender, the only thing you see is faster painting on the web. Super exciting. So I've talked about a bunch of big pieces, and I'm sure you're like, sure, okay, you're doing this. Sounds wonderful. But when? I actually can tell you that the answer is primarily by the end of this year. Most of these pieces are going to be in Firefox. Some of them have already landed. Our goal is to have things in Firefox by November, but we want to leave ourselves a little bit of room. Things like WebRender, we don't want to ship something that's buggy. But our goal is to actually have this stuff in your hands as fast as humanly possible. And we can do that because of the power of Rust. Rust lets us say, we don't have to worry about whole classes of memory bugs, right? So we can just say, is it working? Is it working correctly? And we can spend more time verifying correctness and not worry about the security stuff, because if it compiled, it's safe. So that's Quantum. I'm really excited about it. I've actually been starting to write blog posts about the big pieces of Quantum that I've been tweeting on my Twitter account, and you can learn all those things. So I'm just here to tell you that the future is coming. Mozilla loves the web, and we can't wait to show you a leaner, meaner, faster, incredible Firefox this year. Thank you very, very much. Here's some links. I'll be publishing the slides on my Twitter, and I'm looking forward to seeing all the wonderful talks at Frontend United this week. Thank you so much.